All right, number 27, solve the problem, and we have a system of three equations and three unknowns. Our first equation is x minus y plus 3z equals negative 5. Our second equation, 4x plus z equals 0. And lastly, x plus 2y plus z equals 10. All right, notice that in this particular problem, the second equation here has no y. And so that's going to make our job a little easier. And the way that it'll make our job easier is we can go to the first equation and the second equation, and using these two equations, x minus y plus 3z equals negative 5, and x plus 2y plus z equals 10, we're going to eliminate the y variable from these two equations. All right, so we're going to do that through elimination, and you'll recall from earlier in the series we talked about elimination. We need to have additive inverses in front of the variable that we're trying to get rid of. So if we have a positive 2 in front of this y, we want this y to be a negative 2, and we can make that happen by multiplying this whole thing by 2. And that'll give us 2 times x is 2x. 2 times negative y is negative 2y. 2 times 3z is plus 6z. And lastly, 2 times negative 5 is negative 10. We're going to add vertically. So x plus 2x is 3x. The y's cancel. 2y minus 2y goes away. 1z plus 6z gives us 7z. And then positive 10 minus 10 equals 0. All right, so now that we have an equation that has an x and a z, we're going to use this second equation here that also has an x and a z and perform elimination again. So let's line these two up. And to make it a little clearer, I'll move this down a little bit. And we'll have 4x plus z equals 0. Again, we want to use elimination, so we have to decide whether we're going to get rid of the x or the z. In this case, I think I'm going to get rid of the z because it's going to be easier. We only have to multiply the second equation. If we have a positive 7z here, we want to have a negative 7z here. And to get that negative 7z, we need to multiply the entire equation by negative 7. All right. Negative 7 times positive 4x is negative 28x. Negative 7 times positive z is minus 7z. Negative 7 times 0 is 0. All right, so I'm going to get rid of this equation now that we don't need it anymore, and we'll line these two up and add vertically. 3x minus 28x gives us negative 25x. 7z minus 7z goes away, and of course 0 plus 0 is just 0. If we want to get x all by itself, we'll divide by negative 25 on both sides, and that'll leave us with x equals 0. All right, so we've solved for x. Now what we can do to solve for z is take this x value and plug it into equation 2 here, because as soon as we plug in 0 here for the x, we'll have our z value, won't we? So let's come down here. We'll have 4 times x, but x we know is now 0, plus z equals 0. Well, 4 times 0 goes away, and so we're left with z equals 0. All right, so we're almost finished. We now have to solve for y, and to do that, we will use really any of the first equation or the third equation. How about we go ahead and use, I don't know, how about the first equation? So we're going to take x, which we're saying is 0, minus y, that's what we're looking for. We don't have a value for this y yet, plus 3z, so 3 times 0 equals negative 5. And I'll get rid of some of that to give us some room. So equals negative 5. Well, the 0 goes away, 3 times 0 goes away, and we're left with negative y equals negative 5. And to solve for y, we'll divide by negative 1 on both sides. That'll leave us with y equals a positive 5. And there we have it. We've just solved for y as well. Now, with an equation with 3 equations, or rather with a system with 3 equations, you still are going to write your solution just like you would a system of 2 equations to unknowns. This time we're going to write it as an ordered triple, meaning x, comma, y, comma, z in alphabetical order. So x, comma, y, comma, z. And there we have a solution to the system of 3 equations, 3 unknowns. And it's a really good idea, like always, once you have your solution, take the solution, plug it back into each and every one of your equations to test and make sure you get a true statement, right? This ordered triple has to work in all 3 equations in order to be a solution to the system. If it only works in 1 or it only works in 2, it's not a solution. So let's check to see that it works in all 3. So we're going to have 0 minus 5 plus 3 times 0 equals negative 5. Well, 0 goes away, 3 times 0 goes away, so we're left with negative 5 equals negative 5. That checks out. So we know it works in the first equation. Let's see if it works in equation 2, x and z. So 4 times 0 and plus z, which is 0, equals 0. Well, 4 times 0 goes away, plus 0, so we're left with 0 equals 0. It works in equation 2. And last but not least, let's make sure that it works in this third equation here. So we will have x is 0 plus 2y, but y is 5, plus 0 equals 10. Our zeros go away. We have 2 times 5 is 10, so 10 equals 10. That is a true statement. And so we can see that our ordered triple, our solution, works in all 3 equations and is therefore a solution to the system.